Hello, everybody. Thank you all for coming out tonight. It's great to see a full house. Really quick, I know that I promised Eclipse classes tonight. We do have them. I will be handing them out at the end. We'll stick to one per person, but if you absolutely need to, let me know. We'll be able to get two tonight. I do want to highlight a couple programs that we have coming up. This Sunday at 1:30 in Ohio, February 18th, is Toni Morrison Day. She is a beloved Ohioan and just one of the most accomplished writers, arguably, of all time. So this Sunday at 1:30, we will have local poets Vernell Bristow, Donna Marbury, Stevie Knighton, and Scott Woods here sharing their favorite passages from Toni Morrison and talking a little bit about her legacy on their work. So if you're around, come on out on Sunday. And then on Monday night, February 19th at 7 o'clock, we will have a book discussion of Toni Morrison's Beloved. So if you want to come on out for that, please join us. So if you haven't been to an astronomy program, we're very lucky to have OSU in our backyard, so to speak. I've worked with Wayne for quite a few years now, doing summer astronomy programs. Yeah, it's crazy. I don't work for astronomy at OSU. I work at the library. So if you ask me anything astronomy related, I'm just going to steer you back to Wayne. But I did want to highlight we will have a program coming up Thursday, March 7th at 7 o'clock with Dr. Frank. So if you're around, please come on back on March 7th. And then hopefully we'll have some other dates lined up this summer. So continue to check back. A little bit about our presenter tonight. Dr. Wayne Schlingman is the director of the Arne Slettebak Planetarium and also the director of undergraduate studies at The Ohio State University Department of Astronomy. Dr. Schlingman joined OSU's Department of Astronomy back in 2014 as the director of the planetarium. He received his Ph.D. from the University of Arizona, where he worked with Ed Prather and the Center for Astronomy Education, doing research on the teaching and learning of general education introductory astronomy, as well as Yancy Shirley studying star formation via dense gas tracers in the Milky Way galaxy. If you're like me and miss some of that, tonight's presentation is on eclipses. So Dr. Schlingman most recently won a 2023 Community Engaged Practitioner Award from the Provost office, and I've got to say it's well earned. Wayne does so much work in the community, so we're lucky to be joined by him, and thanks again for coming out.
Thank you. Thank you, thank you. It's fun to be here, and I do enjoy working with all this stuff and giving talks and working with the libraries. It's really great. Our libraries are some of our best partners in Central Ohio. But we're going to be talking about eclipses. Am I ringing too much? Okay. So what is happening here? Anybody know? Yes, yes. Observations are key. Observations are key, and that's very important because this is boring, this is boring, this is kind of cool, this is the 4-minute magic point, and then this is all boring again, right? Like, we get to see the sun do partial eclipses fairly often, not all the time, but fairly often, compared to when we get to see this. This is a really rare event, and that's what we're going to talk about tonight. So I want to talk a little bit about why eclipses are so cool. And so this is all going to be centered on Ohio. I did change our numbers to add in the stuff for Columbus. Sadly, they're really boring, so we're going to also show you the numbers because I gave this talk at Lima, and that's a good kind of central point in the path here in Ohio. So it'll be, maybe a minute earlier in Dayton and a minute later when we go to Cleveland. But this is the magic map. This is totality. This is where the fun happens. This is like going to the shoe when Michigan and Ohio play the game and we win. But this is the fun part. And then here's Columbus outside of the fun part. And that is because the eclipse begins at 1:55. So that's when the sun starts to be eaten like a cookie. So Cookie Monster is totally going off for all of this stuff. So this is when Cookie Monster starts to eat the sun. This is when Cookie Monster says it's had enough. and doesn't eat all of the sun, and then he spits it back up, and the eclipse ends. But notice that this does not say totality, because in Columbus, it will never be safe to take off your eclipse glasses, not even for a minute, for any part of the eclipse. So that means anybody who's interested in seeing totality will have to head this direction and go experience the magic that is a total solar eclipse. We'll talk more about that, but that's just sort of like if you haven't made plans yet, you should be making plans. And given the amount of people that might be moving, especially to potentially the one clear spot or something like that, it could get real fun. But we have been planning for this for almost 4 years, so it's kind of exciting. So what is an eclipse? Simple definition is that when you're obscuring light from one celestial body, the sun in this case, by another passing between us here on the Earth and it. So this can happen when the moon is between us and the sun, or the Earth is between the sun and the moon. So this is a partial lunar eclipse. So this is when the Earth is passing between the sun and the moon. So they're still going to be all in a line at some point. But we can see the Earth's shadow blocking out part of the moon. It's really cool. Lunar eclipses can be seen from any part of the Earth that is having nighttime when it occurs. So they are a bit more common for us to see because they are easier to see because everybody on the nighttime side of the moon can see it. And when you have a total lunar eclipse, we get those blood moons. And I think, don't quote me on this because I can't remember, but I think one within the next few years, the moon visible from Ohio will pass straight through the center point when the sun, the Earth, and the moon will be perfectly lined up. It's going to be really cool. But it's red. That's the thing. So we get to see red light. Does anybody know why the moon turns red during a lunar eclipse? Yes? Exactly. So if you imagine that you are standing on the daytime side of the moon, you're looking back at the Earth during a full moon, you're behind the Earth. What part of the Earth do you see? Night. We see the nighttime side of the Earth. And what happens between nighttime and daytime? Sunset or sunrise, right? And what color is the sky at sunset and sunrise? Red. It's those red rays that instead of just stopping, they can get bent. That's the refracted part. They get bent by the Earth's atmosphere, and then you get a little bit of it that hits the moon and causes the moon to glow red. So it's because we're looking at sunset and sunrise that we get to see that red color, and we get those blood moons. So it is really cool. They are really fun. But what about a solar eclipse? So solar eclipses are awesome, and as much as I said that partial eclipses are boring, they're really, really cool, but they are not the magical moment. But we get amazing photography of these crescent suns as the moon is passing in front of it. Shadows change. You get gorgeous photographs. So there's a lot that we can see even when we're just experiencing a partial eclipse. But this is totality. Totality is when the moon completely covers all parts of the sun. So we are not looking at any part of the sun's surface. And because all of the sun's surface is blocked, it is safe to take off our eclipse glasses and be able to see what's going on in the sky. And instead, what we see is the shadow of the moon blocking out the sun, and we see this kind of crown-like thing, which is called the sun's corona, or the sun's crown. This is the outermost atmosphere of the sun, and we can't see it unless the sun is blocked. It's very, very faint compared to the very bright photosphere or surface that we see of the sun. We're going to see some more pictures of this, but this is the magical moment. And when the sky is this dark and we can see it, we can see all the stars come out, and there's a lot of neat things that are out there. So the difference between a partial eclipse, where we can get cool pictures, versus experiencing a total eclipse is quite different when we're doing it. But let's learn a little bit about why eclipses occur. And we're going to do that by watching a short video from the University of Colorado, where I was a postdoc at the Fisk Planetarium, and now they specialize in making a bunch of science videos, so I wanted to showcase what they did. So we're going to go ahead and learn about eclipses.
Have you ever wondered what causes eclipses? Every year, the Earth goes around the Sun. Every month, the Moon goes around the Earth. Every day, the Earth turns on its axis. Hey, slow that down. The Moon shines because it reflects the light of the Sun. It doesn't produce its own light. Half of the Moon is always lit up by the Sun. Watch its motion during a month. You see that half the Moon is always lit. But during the month, more or less of that lighted side can be seen from Earth, and we call this changing appearance the phases of the Moon. Watch again. See how it looks from Earth. The full moon is opposite to the Sun, and so it always rises about sunset. Did you ever notice that? At the new moon, the moon is in the direction of the Sun. The side of the moon facing us is dark. Also, because the moon rises and sets with the Sun, the new moon is only up during daytime and never up at night. However, every year, there are times when the new moon can block all or part of the Sun, creating a solar eclipse. At full moon, the moon can pass through the Earth's shadow, causing a lunar eclipse. Notice that everyone on the night side of the Earth can see the lunar eclipse. For that reason, lunar eclipses are not so rare. You might wonder, why isn't there a solar eclipse every new moon? And why isn't there a lunar eclipse every full moon? This is because the moon's orbit is tipped about 5 degrees compared to the Earth's orbit around the Sun. We've made the moon bigger so you can see better. If we show Earth and moon to scale, you'll see how small the shadow of the moon is by the time it reaches Earth. So more often than not, the moon's shadow misses Earth when it is new, and Earth's shadow misses the moon when it is full. Roughly twice a year, eclipses are possible. The Earth's orbit around the Sun and the Moon's orbit around the Earth are not perfect circles. They are slightly oval. There are times when the new moon is farther from Earth and is too small to completely block the Sun. During an annular eclipse, there is a ring of fire around the Sun. By the way, when the moon is closer to the Earth than average, some call it a supermoon, though 5% bigger isn't exactly super. If a solar eclipse happens when the moon is closer to the Earth, we call it a total eclipse. You can only see amazing phenomena like pink prominences at the edge of the Sun and the beautiful solar corona stretching across the sky if you are viewing from the path of totality. If we zoom in to see the moon's shadow, you'll see that it has a dark part and a lighter part. If you are standing in the dark part, you are in the path of totality. The Sun is completely covered, and you will see a total eclipse. In the lighter shadow, some part of the Sun can always be seen, so you see a partial eclipse. A lot of people think that if you see a 90% eclipse, you've seen most of the show. No way! The Sun is so bright that even a sliver of it keeps the sky lit, and you'll miss the most awesome stuff. If you possibly can, go into the path of totality. You'll remember it for the rest of your life. Visit the website www.colorado.edu/Fisk or search Fisk Planetarium Eclipse for more information.
Turn it back on. Sorry. That was my bad. So this is 2021, the ring in the sky. the Ring of Fire, the Eye of Sauron, you know, scary stuff. You have to leave your glasses on the whole time, but it is really cool. And then this blue line is our total solar eclipse that we're going to experience here in April. But again, even in the next 40 years, there's not that many places that are going to see a total solar eclipse because the bands are so narrow. And what else do you notice? This was last fall. This is this spring. In the next 20 years, there is nothing. So we have to wait more than 20 years to see another solar eclipse. I mean, we do get one up here, but so we're still touching the United States, but we have to wait a while. So when we're talking about why are eclipses so special, we're talking about their rarity. For most people, they can't fly all over the world. They can't go experience every single total solar eclipse because it's not even remotely close to us. So this event, why is it special? Well, the last annular eclipse we saw was in 1838. This is in Columbus. These are very different numbers because there was an eclipse that passed through northern Ohio, so it was different for them. But in Columbus, these are Columbus numbers. So 1838 was the last annular eclipse that could be seen in this city on the Ohio State campus. And 1811 was before that. And the next one will be 2093. For those of us that are over the age of 20, this is going to be a long shot. Like, I would love it, but at the same point, it's just a long shot. And if we want a total solar eclipse, this took me a while to find. The next one I do know is in 2099. So a few years afterwards, Columbus will finally be in totality. Look at when the last one was. Nobody was here to see it from our families. So it was indigenous peoples. That was it. That was the only group of people that could have seen this eclipse because it was in 1395. So it's been a while since we have had a total solar eclipse here in Columbus. So if you've lived here your whole life, it is okay to have not seen a total solar eclipse because you'd have to live a number of lifetimes in order to see that. So what does it look like? We saw the shadow that they made for the animation, but this is an actual photograph from the 2017 eclipse from the International Space Station. So you can see that shadow and then the small little bit where totality actually is. But this shadow is what moves across the United States. It's that shadow making all the sky dark in it. It's like this big cone of darkness that slides across the surface of the Earth at about 1,000 miles an hour. So when you're sitting there watching it, you have a wall of darkness coming at you at 1,000 miles an hour. It's really, really awesome. It really is. But you also have to plan and not steer aircraft into that because people will freak out on an airplane when all of a sudden it went dark and it's the middle of the day. So what are we going to expect on April 8th? Besides the fact that it could rain, it could snow, there could be 3 feet of snow on the ground, it could have an ice storm, there can be tornadoes and thunderstorms, and it could be perfectly clear. All of those things are possible. So let's hope for the perfectly clear part because it really is worth it. But we're going to start off with a beautiful day. Maybe there's some clouds, but still, beautiful day. Then the eclipse begins. And as I said, Cookie Monster begins to eat it. So the moon, in this case, is Cookie Monster, and is going to slowly devour the surface of the sun. Now, just because there's clouds in front of this does not mean that it is safe for you to look at it without eclipse shades. You must always be wearing them whenever we can see the surface of the sun. It's just too bright. Sunglasses do not cut enough out for us, and looking through a camera is not any better for you. It's not good for your camera either. But as this happens, you put filters on in front of your camera, you can get some pictures. But we're going to see the moon moving across the surface of the sun. So now, nothing is different. You walk outside, and unless you look at the sun or make a pinhole viewer in order to see the shape of the sun, you will not notice that anything has changed. We get to about half of the sun covered. Your eyes, if you're wandering around outside not paying attention, will not tell you that anything has changed. Because it's still bright, even though half the light of the sun is gone. Our eyes don't work in linear fashion, so they're just like, nope, this is still normal. But the shadows might start to look a little bit different. Otherwise, you don't notice anything. This is when everything starts to get a little bit weird. Because once we've hit like 80, 90%, now you notice that it got cold outside. We're missing 80 to 90% of the sun's light. You've noticed that it has cooled down a lot. I'm going to go put a sweatshirt on in the middle of the summer in Arizona because it got cold. Because this has happened to me before. That's how I know that. But also, at this point, every shadow is weird. When we normally look at the ground and we normally see all the shadows outside underneath trees all summer, those are small overlapping images of the sun made by millions of pinhole cameras through leaves and everything else. So when we see the fuzz at the end of the side of a building, that's because the sun has a size on the sky and it's blurry because part of the sun can see different parts of the ground. At this point, it's now a crescent sun illuminating the ground. Every single pinhole that we would see, so if you cross your fingers like this, is going to now show up as a crescent on the ground. It changes the shape of shadows. And as we go past this, our eyes are now saying, like, no, this is weird. For those of you that remember CFLs when they first came out, and it was like walking into a seance where everything was just weirdly dim, and it just felt weird when you walked into a room, that's what the light everywhere is going to be. But as it gets darker and darker, what do you think happens? I see some people up in the front row that might know. What happens when it starts getting dark outside? What do all the animals do? They go to bed. And what do all the ones that are up all night do over on this side? Nocturnal animals. We go to the dark time. What do? They wake up. So you're going to see animal behavior start to change as we go from this phase towards darkness. At this point, as I said, you can take your sun's completely covered. You can take off your eclipse glasses. You can see the solar corona. Yes, there are some things in the sky, like UV light is still coming off of the solar corona. It can damage your eyes. It is true, but that's why we're not staring at it for hours. We're going to look at it. We're going to enjoy the entire experience. But we can see the corona around here. And this corona is from a sun that is not active. So the corona is smooth. It's not spiky. But we're going into a period where the sun is going to be a lot more active, and so it's going to have a lot more structure to it. We might also see, for people who have good cameras or telescopes that can see this stuff, we might see eruptions come off the surface of the sun. This is the chromosphere. So the part of the sun that we see that gives off light is the photosphere. So it's the light-giving sphere. The chromosphere is the part that has color when it's blocked out. So it's just the sun's atmosphere. It's hot hydrogen gas. And then we have the corona, which is really faint on the outside. So those are the different layers of the sun's atmosphere that we can see. With the sun being in high activity, we can see eruptions off the surface and all sorts of fun things. So it might get really, really interesting when we're observing. So this is our totality. What does it look like in person? This is my picture. It's terrible. I was in Wyoming to watch the last eclipse, and I wanted to do it very quickly, but this is in the middle of totality at 2 o'clock in the afternoon. And everything in all directions is sunset, 360 degrees. And the sky is a dark blue. This eclipse is going to last twice as long. The sky is going to be significantly darker, and because it's going to last for twice as long. And so you can see lots of cool stuff. The planets will come out. There are 5 planets that will be visible, potentially a comet. If there's an enormous eruption off the sun that happens to hit the Earth, we could also see the northern lights. Like, things, it would be really rare if that actually happens, but it's possible. We can imagine it. So it's really cool. And then as soon as this is done, you basically just do the whole process in reverse. But that's when everyone gets in their car and then a million people try to go home. And that's when a whole different party begins. Now, for those of you that really love baseball, Guardians' opening game is on April 8th. Because they want people to sit in Cleveland and stay in Cleveland, because you can be at the ballpark for the eclipse, right? It's totality right there. So you can do that and go watch baseball and just stay and hang out and have a blast. So that's sort of what the experience is going to be. We're going to have a lot of things happening. The sky's going to change, but it's also feeling the temperature changes and listening to the animals get quiet and go to sleep, and the other animals waking up and then suddenly changing. It's 4 minutes of nighttime, and then they all get mad because they're awake again. But you're going to experience this with more than just looking up in the sky. And so that's something to keep in mind, is that don't waste your time taking a lot of pictures. Try to enjoy the whole experience. So why are scientists interested in eclipses? Because we don't get to go and study the sun's corona that often, because if we go to space, you still have the sun and you can't always put the moon in the way. And so we don't get to study it except for when we can line up our telescopes and block out the light. Or sometimes build what we call a coronagraph, which blocks out the light of the sun. So what do? Well, sometimes we chase eclipses. So we'll get very fast airplanes, and NASA will put a whole bunch of equipment on the back of them, and then they will fly along that eclipse path as fast as they can to try to stay in totality as long as they can in order to make measurements. So in this case, they are looking for high-frequency pulses in the solar corona, so that's eruptions that are happening on the surface, and watching them ripple through the corona. We're trying to figure out how the sun's surface and the sun's high atmosphere, the corona, how they talk to each other. That is not a known thing. And so if we figure out how they talk to each other, we might figure out what makes the corona 1,000,000 degrees versus the sun's 5,000 degrees. Very different temperatures, but we don't know how they talk to each other. We can also learn about our own atmosphere. So in this case, this is where the shadow is. So this is from 2017. And we're looking at all the measurements being made of the Earth's ionosphere. So this is a high level of our atmosphere that is usually during the day hit by UV light. The atoms break into ions, so ionized. And we can see, like at nighttime, they would recombine, but we can see this nighttime and daytime transition really, really fast, and actually the ringing that can occur in our atmosphere. So it tells us something about how our atmosphere works. And we can see these rings before and a little bit afterwards of these small little shock waves that are rippling through the atmosphere itself. Now, something that it makes sense when you think about it, but where do we get our power from? A lot of it now comes from the sun, solar energy. That includes wind energy, because the sun helps drive a lot of the convection currents we have. So what happens when you block out 100% of the sun in some spots, or 90% of the sun across a big swath of the country? You have to plan ahead. So we need other alternative power sources to be turned online during days of the eclipse. So this is why planning happens. Like, industry is paying attention to this, because we need to know, well, where are we going to get the energy from? How do we get things into the right path? How are we doing how do we do all the logistical problems, including not have airplanes drive into totality unless they were meant to drive into totality, because we don't want people freaking out. So these are all things that have to be planned in advance and moved around. But it's a lot of the science together that helps us understand the different parts of our atmosphere. So I bring this up because the ionosphere is up high, and so that's what they're trying to study. But all of this can glow due to particles from the sun coming in and hitting the Earth. So I said we were going into solar activity. We're reaching a peak in solar activity called solar maximum, where there are a lot of sunspots on the sun, so it's interesting to look at. If you want to look up the Solar Dynamics Observatory, you can get cool pictures of the sun every minute of the day. But we track the sunspots, and the sunspots tell us about this solar activity. And sunspots are magnetically active areas where the magnetic field of the sun gets twisted up, and sometimes it snaps and it breaks. And that's where it can eject a bunch of material and hit the Earth. Those things are cool. So we're coming up to this solar maximum. So we're going to be observing the sun while it is very active, so it's going to look different. The boring solar minimum, like we had in 2017, versus the very exciting solar maximum this year. So the corona could be really, really exciting to see. And we could potentially see some of these eruptions take off. Like, big things can happen on the sun, even though they're rare, but they could happen while we're out there just hanging out. If you want to take a picture of the sun, and someone has like a solar telescope with an H-alpha filter, this is what we'll see. So this is the chromosphere. When you block up the entire rest of the sun, this part will glow bright red. When we look at the sun in just that red wavelength of light, we can see all the structure that's happening across the surface, but we can see all the areas that are lifting up and down and sometimes making these huge loops that are bigger than even the planet Jupiter on the edges of the sun. And when those do lift off, that's when we can get the aurora borealis. So one of the things to be paying attention to is if there's an aurora alert on the news, or you can look up for some auroral forecasts, because as we reach solar maximum, it's not just, hey, this is going to be cool for the eclipse, but we could see this every night. And we could have seen this in the fall if the weather was a little bit better. We missed it. It was really cloudy here, but if Arkansas can take beautiful pictures of the aurora and it's not just on the horizon, but it's nice, decent display up in the northern part of their sky, that means we could have really easily seen it here, but it was raining that day. So, but these are the types of things that as we're going through that solar maximum, like we could have events that could be overhead in Columbus. It's possible to have those events. So my big push, eclipse safety. Why glasses are very important. This is a great website to go to. If you look up the AAS, that is the American Astronomical Society, and Eclipse, both NASA and the AAS have a lot of the same information on their pages. But if you just go to eclipse.aas.org, you can find out any information you need about any eclipse glasses or viewers or how to do this safely. I briefly summarized it here. Mostly, you need to pay attention to this number. That's the number that you need. You need to be careful of where glasses were made, and that's why it's important to go to the website, figure out who the manufacturers are, so that you know you're getting a manufacturer that is well known to produce good quality eclipse glasses. But the biggest part is, if you have a pair of glasses, or the glasses you get tonight, let's say you scratch them, are they safe to use now? No. So you want to protect them. Pretend that they're like your really expensive like eyeglasses, right? You don't want to drop them on the ground and then just put them back on and say everything's totally fine. You need to protect them, and they need to be in good condition when you use them. If you have kids or young humans that need some help, there are ways that you can tie them on to keep them on their face. But the biggest thing is whenever we practice with any of this, glasses on, and then we look up to find the sun. So that way we're practicing. We're not looking at the sun and then figuring it out. There are people that try to do that, and it's not good for them. But we put our glasses on, we be safe, we look at it, and then we can look back down and we take our glasses back off. So that's what we want to focus on, is being very, very careful. And if we don't have glasses, you can make pinhole cameras, and I'll show you here in a second, that allow us to view the sun indirectly, because we're all going to be turned the wrong direction. The sun is behind us, and we're going to be looking this way. So it's a safe way to do that, especially if you're going to be large groups or large groups of kids. And then basically, once we hit totality, once it's completely dark and you no longer see anything through your glasses, then you can go ahead, take off your glasses, enjoy the solar eclipse, like the total solar eclipse, for as long as it is. You can estimate what that is on that map, and we'll bring it back up here in a minute. But if you're at the edge, it could be 10, 15 seconds long. But if you're in the middle, it can be up to 4 minutes. So you want, there's a big difference in that one, but you want to just be careful and be ready to put your glasses back on once it's over. So my parents' dog, totally prepared. They're together. They're making sure that each other are wearing their glasses correctly. So you do want to, animals aren't trying to look at the sun, and they're just going to probably go to sleep. But if you're around a lot of people, don't bring your animals out. That's just another good thing, because there's going to be a lot of people in Ohio. So pinhole cameras, you can just use a colander. You can do all sorts of art with a bunch of kitchen supplies. So here's a slotted spoon. You can do this. This is where I was saying you can do your fingers up like this, make some holes, and you can see those crescent suns. In some cases, if you have a telescope that's set up properly, you can create a projection screen that allows you to see what the shape of the sun is at that time. Because it's early April, we may not have leaves, but underneath a bunch of leaves, you would see thousands of pinholes, all shapes of the sun, the same crescents over and over and over again. And that's where I say the shadows will begin to get weird. So instead of just seeing oh, it's a blob, that's the full disk of the sun, we're going to start to see all the crescents. And so everything will start to change as we're doing that. So because I gave this talk up in Lima, that's what these times are for. But over here, we're about a minute or two earlier, and up in Cleveland, we're a few minutes later. So you can kind of see how this is moving across. But basically, if you get out into totality, right around 3 o'clock, 3:10 is where the magic is occurring. And we're going to be able to see the sky go dark. Even if it's snowing outside, the sky will definitely go dark. All the street lights will turn on, and it'll be a really cool experience. If you want this map, that's where this map is. But if you have any questions, this comes to me, but solareclipse@osu.edu. And with that, because I could talk for another 2 hours, I'll take questions. Yeah? Yeah. So this is the edge of totality. So here is where it'll last maybe 10 seconds. In the center is where it's going to last a lot longer. So each of these lines represents, I think this one's 1 minute, 2 minutes, 3 minutes, and then down in here, in this circle, it's going to be 4 or more minutes. Yeah. Yeah, that's just saying that this 315 is in this circle. So you want to be in between these. So the M in Mansfield is very close to the center, so it's going to be asking a long time. So Mansfield is more towards the edge, but anything that's in this area is going to get a really good view. NASA Glenn said that Lake Erie is supposed to, push the clouds back, so they're pushing for a lot of people up in these areas, but yeah.
So I was planning to go to a friend's farm near Athens.
Okay.
So I see nothing there.
So in Athens, you're going to be down here. So you're going to see that partial eclipse. It'll be like 95% coverage.
Okay, so it was
Go the other direction. Grab your friend and go the other direction. And like some of the rules, so I've been working with the state emergency management agency for about 4 years to help plan